In the xy plane, lines P and Q intersect at point 0,5. Is the slope of line Q negative? So we want to determine whether the slope of this line Q is actually descending from left to right. What we know is that two lines intersect at some point on the vertical axis, the point 0,5. So over here, two lines cross this point exactly. We have a statement 1 that says that the x-intercept of line P is negative, so that means that line P should be something like this, with this x-intercept negative, so this makes line P with a positive slope. But what about line Q? We have no more information, so line Q might possibly be a line with negative slope. It could be a line with horizontal or no slope, that is zero slope, or it could be a line with positive slope. There is nothing that prevents any of these three cases. So the slope cannot be determined. Statement 1 alone, not sufficient. What about statement 2 alone? Statement 2 alone says that the product of the slopes of lines P and Q is negative 1. So what does that mean? It means that these two lines cross each other perpendicularly. When they cross perpendicularly over this point, that means that we have a line like this and perhaps a line like this. So they form a right angle or 90-degree angle at their intersection. But which one has the positive slope and which the negative slope? It might be the positive slope for P and the negative for Q, or vice versa. So we don't really know. We have no more information. Statement 2 alone, not sufficient. When statements 1 and 2 are taken together, then we might say that if we have two lines, perpendicular lines, crossing at this point 0,5, then if they cross perpendicularly, clearly, one of them must have the negative slope and one of them the positive slope. So since the one with the x-intercept negative is P, then the other must be Q. So Q is clearly the one with the negative slope. The answer to the question would be affirmative. So the correct answer choice would be both statements together are sufficient, but neither statement alone is sufficient.